Okay, welcome to the Defen episode number 32. This is Vijay from Holland.
Hi, it's Ray in Belgium.
And Conrad from Chicago.
The Windy City.
Yep, it is.
So, we are very excited to have you, Conrad, finally on the episode. I think we've been, there've been some uncertainty whether we're going to record it today or not because of us, but I'm glad we made it. So let's get started. I'm sure there will be, of course, we are live streaming this episode just like the previous two episodes. So if we have any questions from people who are watching around the world, we'll pick them up somewhere around the end of the episode. So first of all, welcome to Defen. So did you hear any of our episodes, or what do you think of this podcast? First of all, advertisement for Defen.
Yeah, so I've been listening to it for a while. I'm a big podcast listener. I spend so much time in front of a monitor, and since I'm sort of a datavore, somebody who likes information, there's only, since I spend all my time programming in front of a monitor, I consume most of my reading material and news by podcast or by Audible and those kinds of things when I can. So I've been listening to you guys for a while. And I've been really impressed by the caliber of the guests. So the quality is really high. It'll be tough to follow. And and I thought the overall structure and the kinds of questions were really well done. So I'm a big fan of Defen.
Wow,
fantastic!
No one's ever been crazy enough to admit that before, Conrad. So it's appreciated.
Exactly. I think we're going to quote you on our website and everything, and then we put the GIF of you everywhere, and then we say, he said we're good. So, okay, so let's do a quick round of introduction. Of course, I mean, most of the people already know about you, because you wrote this LISP book a long time ago, Land of Lisp, and you did a lot of work with Clojure as well, starting from WebFui and different things. So we talk about all those things. So how did you get into Lisp?
So I've been for a long time a kind of a low-level C and assembly language programmer. So I a long time ago in undergrad, I worked for a contractor that was building Atari video games. So if you guys remember the ill-fated Atari Jaguar console, so I was lead developer on a game for that a long time ago. And that was lots of very ugly assembly language. So that was kind of my background. And of course, I always kind of been interested in like kind of the tooling and like figuring out like, what is the right way to write a computer program and those kinds of things. And so I did a lot of stuff in C and C++ and kind of went down that rabbit hole, and then quickly started realizing, this language doesn't really do what I want. So I guess I'm going to have to start writing some kind of preprocessors to so that I can like use this tool the way I want to. And so I kind of went down that road. And then I was listening to an interview with Bjorn Sturstrup. I probably totally butchered his name, but he
it's okay. He doesn't listen to this podcast.
Yeah. And so they asked him like, what if we want to see what the new ideas are going to be in C++ moving forward, where should we look? And he said, well, look at what the functional programming people are doing. And that was really the first time I'd heard that term. That was quite a while ago, and it's like, okay, so what's this? And then I first, if you look up functional programming, pretty much the first thing that'll come up is like Haskell and that type of stuff. So I went down that rabbit hole for a while, and those are really cool languages. And then I guess sometime around that time, I also started reading the Paul Graham essays. Where he was speaking very highly of Lisp, and then I kind of realized, I kind of like this these languages that kind of make it easier to do prototyping, where you can just kind of start building stuff, and you don't have to worry about what your type signatures are and all that. And and then of course, what's awesome about Lisp is that it sort of fulfilled my old dream, where it's like, oh, now I don't have to write a preprocessor. I can just write macros. And so I went macro crazy like every early Lisper. And nowadays it's like, once every 6 months I write a macro, because you learn, the more you do it, the more you realize you shouldn't be using macros for everything. So that's kind of how I got down that rabbit hole. And I mean, I think what sort of distinguishes me because I have kind of a different background, both because I went into medicine, and also just because I came out of a part of the country that wasn't really very sort of a tech area. I came out of South Florida, and and before the internet, it was really hard to get sort of good computer science information. There wasn't. So if you wanted to be an autodidact, and which I was because I wasn't getting a computer science degree, there wasn't a lot of information. So I kind of got into all of this sort of the computer science side of computer programming rather late, and I think that gave me kind of a unique perspective in that I could, maybe explain some of these concepts more easily to beginners because I was also kind of a beginner that had just kind of picked this up and was really excited about it. And so I think that's why, like the early web tutorials I did around Lisp programming, like the most well-known one is called casting spells. I think that's kind of why it hit a chord, is just because it got people excited, and it could explain kind of in a very basic way why these things are kind of interesting to somebody who it hasn't done macros and hasn't dealt with homo iconic languages and that kind of stuff. So,
but as a person who is, as you said, you're kind of an outsider for computer sciencey stuff, and so how did you feel between Haskell and Clojure? I mean, you went into different sorts of languages. So, and without any computer science education, because if you get computer science education, then you start with, I don't know, types and type theory, and if you go into that direction, then suddenly things are a bit different than coming to the real world programming, so to speak.
Yeah, it's really weird, and I'm still kind of ambivalent about this whole the whole argument about static typing, because part of me really feels like if I was just kind of smart enough that and I spent enough time using Haskell and OCaml and all the ML languages, that that might be like the most effective way to write robust computer software. But I have to live in the real world, and the fact is that I can just write a lot more code in a dynamic language like Clojure. So I don't know how to explain that difference. The difference could be that maybe if I put in just another year of Haskell under my belt, then I would be just as good in Haskell. Or it could be that the idea of having to think really deeply about types at the beginning as you're developing software, that maybe isn't like an optimal way to develop software. I really don't know what the answer is. Clearly, in the Clojure community, there's sort of this view that people have had recently, where they've kind of said, well, maybe this being so heavily statically typed might not be the best thing ever. Maybe there's actual tangible benefits to not going down that in that direction, because although it does give you certain guarantees, the guarantees are still limited. Types are not a silver bullet, and so so there's trade-offs, and it's really hard to judge what the right answer is there. I mean, I think I would recommend for anybody who's a serious programmer to learn both a statically typed language and a Lisp language.
Yeah. Going back to when you started to learn Lisp, because you said you worked on games, did you look at implementing some games in Lisps, or were you just looking at something completely different by that stage?
So that's a good question. So, I mean, the casting spells in Lisp that I did was a game, a text game, because I liked it. I was kind of intrigued by how a REPL is so similar to something like Zork. And it kind of seemed like the natural way to do like a tutorial. I mean, I was a kid, when it was the early 80s, I would pick up those books like 110 basic computer games, and I would type them all into my Commodore 64. And so I really like that idea that you there's something about games that lets you take like abstract concepts and very quickly build something tangible that has some kind of utility. and it's just a great way of learning. And so the Land of Lisp book is basically the design of it is that every chapter has a game in it, and the hard part with the book is that every game could only use concepts that were covered in previous chapters with previous games, and so it was very difficult figuring out the right ordering of the games and features in the games to make that work. So,
yeah.
And how did you find that from a kind of like, let's say, I mean, from an experiential perspective, I guess it was pretty good, otherwise you would have given up. But how did you find it when you were like comparing it for, people always say, oh, you can't write games in this stuff because it's too slow and it's too, it's too difficult to kind of make a performance when you compare it with, assembler or C or even JavaScript or Go these days, I don't know. But certainly like, Objective-C or C++, people are writing all their games in that. So do you feel like there's a subset of games that could be written in a Lisp, or is it just kind of like purely as a toy?
Well, I kind of think that the things that I find interesting and compelling about games, like I was a big fan of the Ultima series, has very little to do with graphics and the performance you need to do interesting things in games in terms of storytelling and stuff is not it's not a very high bar, and certainly with a modern Lisp, you can do actually pretty high performance stuff if you want to. I mean, it's always a tough question exactly around what role does optimization play in any sort of software that you develop. Yeah. And I'm certainly somebody of the view that I like thinking about new ideas, and I'm just somebody who likes building things, and for the most part that means that I pay very little attention to performance or optimization because that just gets in the way of trying out new ideas.
Preach.
Yeah, and when we talk about development frameworks, that attitude will come into play, I think.
Yeah. No, that's awesome. I totally agree with that. I mean, I think it's a trope, isn't it, that you should get everything correct and right and happy first, and then find out where the performance issues are and deal with that later. And even if you have to throw it all away, you've still got the thing that you want right.
Yeah. I think there's a definite case for writing software in Lisp. Like if you're talking about high performance stuff, like code for some embedded system, like the way I would probably go about that if I had that job is I would write it in something like Clojure with the expectation that the code would be thrown away. But after I got everything working in Clojure, then I would sit down and figure out, okay, what are the types? And then I would use some very performant statically typed language to write all the types out and then code the rest of the system and then use that. So, but certainly for that early exploratory phase, Clojure seems to be kind of a local maxima. And it'll be interesting to see, because it could totally be that 5 years down the road there'll be. I mean, I think there's starting to be room for new programming languages now. So we'll see if there's another Rich Hickey 5 years from now that comes up with something even cooler. But so far, Clojure seems to be pretty ideal.
I think the other thing I'd be interested, because I'm doing some IoT stuff as well at the moment, and I've seen some videos of people doing Lisps for embedded systems, sort of mini versions of Lisp that can run everything in a Word, and they can do all kinds of optimizations. So maybe this Lisp machine, maybe the IoT will be the place where we start to get the Lisp machine coming through again, because people want to be able to code in a Lispy way. I mean, having a REPL on the IoT would be superb, I think. At the moment, I'm writing all of it in C and waiting for a long loop around before you can get any work done on these things.
Yeah, and I think later on when we get into the discussion where we start talking about blockchain and smart contracts, that same issue comes into play, because with these systems where you want other people to validate your computations, performance and optimizations are very important.
Yeah.
But did you? So you started with programming I'm assuming as a hobby, not like really as a study, because doing medicine must be pretty exhausting and time consuming. Doing that education, and then you moved into obviously learning all these languages, and now these days you're working on the blockchain stuff. We'll get to that point. But how did you manage to do the programming stuff? Did you work commercially with, building software for somebody, or?
Well, I mean, I'm an older developer now, in my mid 40s. So, I come back from the era where you didn't really need a computer science degree to work at a software company.
Yeah, I
And
think even now it's more or less that is the case. I mean, if
Yeah.
you know JavaScript, then you're a software developer. So
yeah. I mean,
Yeah.
a degree is more helpful now, but back
Exactly,
then, basically nobody cared.
yeah,
And I just realized, like the guy that we've hired for our company, that's been working for us for a long time. At some point I realized, hey, I don't know anything about you. Did you get a computer science degree? Did you graduate high school? Because it doesn't matter. Because I know, I knew his work, so that was completely
Yeah.
irrelevant. It never occurred to me to ask him any questions like that.
And then you started now. So do you practice medicine, or are you fully focused on your company right now?
No, I basically got my medical degree, and
Okay.
I kind of while I was at medical school, kind of decided that was probably not the right career choice for me. I think just temperamentally, I'm not very good with just rote memorization, and I'm not very good with sort of quick in the moment decision making, which is a big part of that job. I'm somebody who likes to sleep over things, and then I make good decisions the next day. So like computer science is like more up my alley. But it doesn't matter if you have a medical degree and you
can
have a computer science background. And this was right before the .com bubble when I started going into working for medical enterprise companies. There was just easy demand. People were interested in hiring you. So computer software makes a pretty decent salary too compared to what a resident doctor makes. So I could pay my loans back and everything in the same way, pretty much. So
Yeah. So you transitioned from Haskell to Lisp. Obviously, I mean, you wrote Land of Lisp, which is super fun book, and with all the fancy Lispy alien stuff and everything. It's amazing to read and really fun. And then you did a bit of Racket as well.
Yeah, I played around with all the different Lisps at one point or another. And in fact, when I was approached by No Starch Press about doing Land of Lisp, so they had seen my online tutorials and thought I might be a good person for a book. I told them, there's this new language called Clojure that looks kind of interesting, and we all decided, well, it's probably a little too early to write a Clojure book, so that's why I wrote Land of Lisp. But if it had been another 6 months later, it might have been Country of Clojure.
That's nice. I mean, you always pick these words with some sort of a rhythm in it. I mean, Bitcoin for the befuddled, and Realm of Racket, and Land of Lisp.
Yeah, I don't know why. I guess it just I like titles that roll easy off of the tongue. So
it's very easy to remember, right? I mean, if you say, "Oh, which Clojure book was that?" It's much easier to remember which Lisp book was that, because I've read enough of Lisp books, and I think the only book name that I can completely remember is LOL, Let Over Lambda.
Mm-hmm.
That's like a really mental gymnastics with macros. I mean, by half of the time I read it and then I go reread it again, and then I'm like, okay, I don't understand anything anymore.
Yeah,
it's a wonderful book.
Yeah, it is a great book.
Yeah,
great book that you don't understand. Yeah, most religious books are like that, aren't they?
Exactly. the thing that you don't understand is above your. Then you suddenly start to revere it with some level of admiration, and then.
So it's a life of a whole life's work of study. So
yeah.
Yeah.
So why? Because you started doing the blockchain stuff. Before we get into blockchain, I'd like to, I think, let's discuss a bit more about. I remember watching the video was it Clojure Conch? Because you presented WebFui.
Yeah.
What was the background for that one?
Yeah, so this was just me. So at my day job in medical enterprise software, very very conservative field. It was all about ASP.NET, and so I was doing a lot of C# programming, and we were doing we were just starting up JavaScript development, and but yeah, I just kind of realized that I'm a functional programmer. I want to write functions that say that output as a result what I want to see on the screen. And I had heard there's a thing. What is it called? McClim. It's a thing from the Common Lisp world, and they started playing around with some of those kinds of ideas. But for the most part, just at that time, the concept that you would have an app that just is a function where you stick in the information about the app, and then it spits out what you want to see on the screen. Like that hadn't really existed in like a major way at that point. And so I just basically what I did is I just wrote a function that would just spit out HTML, and then I would just say in JavaScript, like window.html or inner HTML or whatever it is, and then I just say equals to this big thing, and then you can write an app that way. It just it just kind of spits out the HTML for the page, and then of course the next thing you start thinking about is what should be the correct way to have some sort of modularity and some kind of composability. And that's where I kind of got it wrong, because I thought, well, I basically I want this function that just dumps out HTML, and then if we want to like break up the screen into different components, the way I would handle that is by just having more functions, one for each component. And I didn't have the actual concept of a real sort of component design, which with the idea being that each component has kind of its own needs in terms of its own state and sort of its a life cycle where it can be mounted and unmounted and stuff like that. And so anyway, so I built this web GUI thing, and it was surprisingly hard to kind of figure out how to do this low level manipulation of the DOM. And at some point I optimized it. The next obvious step is, if we have a copy of the old HTML and we have the new HTML, both of course in an Eden format, Clojure Eden format, then we can do a delta. And so instead of replacing the whole screen, we can just replace little pieces based on that. And then now you've gone to the point where you're building your own virtual DOM engine. And it was there was like no resources on this. Nobody really had done it before, or at least not publicly. And so that's what I presented at that Clojure Conj. And then a couple of months later, Facebook released React. And then when I saw that, and the thing is, like, I didn't really want the job of developing my own web framework. It's just like, hey, the web frameworks like don't work the way I want to. Like, I want to work in a way that I want to work. And so the only option there was to build my own. And then as soon as React came out, I was like, thank God, because like my framework was kind of not a really solid implementation. It was very rough because it was just something I was doing in my free time. And so, and then I like went straight to the React forum, and it's like, you guys have totally the right idea. This is fantastic. I was working on the same idea, but I don't care, because like, it's great that these good ideas are being implemented. And so I was like a big champion on day one when React came out. And if you looked at the Hacker News story when React came out, everybody was like, well, this is just the dumbest thing ever. You're mixing your CSS and your HTML directly with the JavaScript. Like that, like what kind of idiot would do that? And that's how React was for like the first 6 months. Everyone hated it. And then somehow people started realizing the benefits of this approach.
So you started from web GUI, and then you obviously React people stole your idea and then somehow made it more popular. That's pretty good for all of us then.
I should point out they were working at it for like even a year before then.
No, don't do that. Don't point that out. No. You have been thinking about it for years before you started on it, so come on.
Exactly. They stole the idea. Anyway, we're gonna spread this thing around. But anyway, but you get, of course, I mean, it's a very exciting idea. And then there have been a lot of frameworks in Clojure which adopted React, and then they build different things. Then how did you, because you recently announced QLKit. So why QLKit? When we have Reframe, when we have OmNext, when we have Fulcro, Rum, Quotient, whatever. There are millions of things these days.
Yes. So So I really, uh, I mean, the big problem you run into, I mean, there's two big problems. Okay, so you figured out finally how to handle the information on the screen. React solves that beautifully. The two big problems you have to deal with next is that there is not a one-to-one mapping between your client application state and your UI. So basically,
Yeah.
I guess the term would be it's a DAG. There's
Yeah.
if you have friends, you may have one. You're building a Facebook app and you have friends. Then there might be one place where you see a list of your friends, and then in a completely different part of the UI, it'll say you have 10 friends, and if you unfriend somebody on this side, it has to update that count on the other side, and you have to manage that in your application state. And so now you have this problem where you have different parts of the UI that need to share the same backend data. So how do you solve that? So WebFui totally didn't address that question, and the first and even things like the early React and some of the early frameworks in Clojure didn't really address that. The first one that I really saw that addressed that was Ohm, the first version of Ohm. And so what David Nolan did there is he had this concept of a cursor, which was kind of a complex. I won't get into it because he's already moved beyond that.
Exactly. Yeah,
but it's kind of like a fancier version of a zipper, and it basically kind of keeps track when you're deeply inside of a component, how that maps onto something in terms of the global application state that you're managing, and so that was really appealing to me. But then I really got into Ohm, and that was like the one that spoke to me because it like solved the next big problem, which is how do we map the client application state to the UI, and but then of course you start messing with cursors and this cursor concept, and you eventually you run into edge cases where cursors just don't work, and where there's complicated enough relationships that you just can't use cursors for it. And then of course if you look up the FAQ on Ohm at the time, David Nolan would said, well, he said, well, you should use channels. You should pass channels between things, and that way you can kind of have things kind of talk to each other sort of out of band and things like that. But then it's like, well, now it's starting to kind of look a little bit like spaghetti, and that's why Ohm was then superseded by Ohm Next. And then I got totally obsessed with Ohm Next. And the idea with Ohm Next was, well, here's the thing. It's really hard for me to really understand what like the underlying abstraction with Ohm Next was. Like, well, what were the priorities that David had in mind? All I can speak to is when I studied it, like the features that I saw, and some of the features really spoke to me, and other ones not so much. And as we discussed earlier around optimization, Ohm Next went to great lengths to offer a really compelling optimization story. And there was some costs with that, naturally. One being that the code base is complicated. And another one is that there's again some edge cases where Ohm Next can be difficult to use, where you have to kind of look under the cover, specifically around the issue of when parent components pass information to child components. Ohm Next breaks that into two categories. One category is things that relate to the application state and the queries that the child components have, and then separately, if the parent just wants to send like some kind of message or just give an extra property to a child, it kind of handles that differently. So I'm not sure how well I'm explaining that, but basically, when a parent component in Ohm Next passes data to a child, there's like two different ways to do it. You do it either as props, which is kind of the React method, but then they have this other thing called computed props, and when you mess around with that stuff enough, eventually, like you again kind of have to look under the cover. And so Ohm Next is really great. But again, me kind of being an outsider, it seemed like there might be some value that I could add by just sort of translating what I view as the really great ideas behind Ohm Next into like a different framework. So that's kind of what I've done. So that QLKit really doesn't have a lot of new ideas. There's maybe a couple, but I mean, I guess I kind of think of it this way, like, why is the English language like one of the easiest languages to learn and for beginners? And the answer is, or people speculate, linguists speculate, that it was all the invaders from the Vikings from Scandinavia that came to England and Britain, and they had to learn the language as adults, and they intermarried with the locals. And because of that, the language greatly simplified during the Viking invasions in Britain, because you're basically taking these very complicated ideas, and you're taking people that are novices, and they have to kind of reconceptualize these ideas in a different way. And there's a benefit in that.
So are you saying that the whole of the Brits were all dumbed down, basically? That's
well, the language was, and it's everybody's benefit. It's part of the reason.
He's only talking about the language, not the Brits themselves.
Well, I don't know. I think Brexit shows that people were affected also. But okay, carry on.
Yeah.
Right, I interrupted you. So we're talking back to QLKit. Okay.
Yeah. So that's essentially what I did. Is I looked at OhmNext, and there's so many awesome ideas in there.
Yeah.
And I just said, if I didn't have OhmNext, but I knew all these great ideas, what would it look like? And that's what QLKit is.
I think that was most of the. Of course, I'm also not an expert or anything. Obviously, the idea behind Ohm and OhmNext has always been, at least that's what I heard from David speaking at the conference, is that this is an idea exploration, and then you can build on top of it.
Yeah,
so
exactly.
This is not the final framework that I'm bringing, and then you should just use this one.
Mm-hmm.
Yeah.
These are the ideas that you can start and then build on those things. So
right.
I think OhmNext was also kind of the similar. Yeah,
it's almost a set of principles. That the client should be able to express their desire in some kind of data type language to the server, and it should get exactly and only what it needs back. I mean, these are the kind of core principles.
Yeah.
Mm-hmm. Yeah. So I mean, David Nolan, he said very clearly that he basically just wants to share ideas, and that's what his goals are. And he's happy.
Exactly.
And it sounds like he's happy when people take his ideas in other directions.
But why not Fulcro? Because Fulcro, of course, I mean, I read your Medium blog post, and I'm sorry I didn't try out the whole QLKit yet. I will certainly next weekend. So you have Fulcro, and then Fulcro. We had Tony K as well on Defen. I'm not sure if you have heard the episode. So he was also doing similar kind of thing, like bringing OhmNext to people like me.
Yeah.
So what did you look into that framework, or any good things that you pick up from there? Or
and I definitely owe some gratitude to Tony K, because I use a lot of his tutorials for understanding OhmNext. And OhmNext does have a pretty high learning curve. And Tony K did a lot of work to help alleviate that. So yeah, I mean, the idea behind what Tony K was doing is, I don't want to speak for him, but it seems like his goals were to add features to OhmNext, and also to apply some opinions to OhmNext. So basically, he said, OhmNext. Back when David was starting OhmNext, and you would ask him, hey, David, how in your opinion, how is somebody supposed to do this particular thing in OhmNext? And then his answer usually would be something along the lines of, that's the beauty of it. You can do it any way you want to, which of course you don't want to hear. You want David to just tell you the right way to solve the problem, right? So that's kind of what Tony did. Is he said, okay, yeah, let's not do that. Let's have a version of OhmNext where it tells you at least a default way to do things. And now, of course, Tony has gone in another direction, which is that he's, from what I understand, is pretty much duplicating the code base from OhmNext. He's like forking OhmNext to be more appropriate for Fulcro. So they're starting to deviate more. So my idea was mainly that what really got me is just the complexity of the code base of OhmNext. And I think the reason it's complicated is, again, number one, because the flexibility that David wanted, and also these optimizations. So if you use QLKit, the only kind of optimization you get is the basic React optimizations that React does, but it doesn't go beyond that. Whereas Next like takes it to a whole nother level of optimization. But there's again some costs in terms of the complexity of the code base. So I was just wondering, well, what if we didn't have that? What would the performance be like, and how simple can we make the code? And so that's kind of what I did. And I think there's a couple of other things that where I kind of differ with QLKit from Next. So I mean, a lot of the syntax and stuff is different. I mean, there are some different views of it. I mean, what I really liked about Next that I thought was a really brilliant idea was that when a component basically declares the data that it needs in a query as part of the component declaration, and this is usually done at this is a static query. So basically, you say that when you write the code, you say this is the data it's going to need. And what's really great about that is that the first thing you do when in Next, after you have these queries and they all get kind of composed based on the component ordering, is you basically just immediately throw them away, because you pass them to a parser, and then you have this separate thing called these parser functions that parse the query, and then after and then they basically what you're doing is you're creating your own language for describing the data needs for all your components, and then you immediately throw that away by giving it to a parser that fulfills that. So it's like you're kind of writing your own language just for yourself, and the query language basically just lives in the confines of your program, and it's more of a in a way kind of an organizational tool for the structure of the program, but it's not meant to really be used in the outside world. And in some ways, Next differs from that. First of all, the Next query syntax was built off of the atomic pull syntax. So that was because of that, it was designed to be more something that you could send to outside entities like Datomic, and that introduced some complexity. And then also there's this view in Next where maybe you can make the query. Maybe the query language should be richer and have more features, so that you don't have to write parsers that are as complicated. So they have these things called links, which is a way to connect queries together in a certain way. And they have parameterized queries where you can basically change a query at runtime. So you can either just change the parameters of a query, or even replace the entire query itself at runtime. And so to me, those actually, I didn't find those ideas very good, because I like the fact that the query never changes, and I like the fact that if we can make the query language really, really simple, since the whole job of the query language is for our own use to parse it. We want to keep that language simple. And so if you read about the Next query syntax, depending on whether you have parameters or not, you like the way the query is structured changes pretty radically. And so there's actually a separate parsing mechanism where they take the Next query and then parse it into an AST query. So they have two different query formats. Whereas with QLKit, I severely restrict what you can do in a query in terms of the syntax, and then you use that in your parsers directly, so that we reduce that extra step. But then of course the very first question when I posted it online was like, if I can't have a dynamic, if I can have dynamic parameters in a component, like how would I do certain basic things, like just having a search field? Because in a search field, the idea is you have a component, it has a query saying, I'm looking for, let's say, a person with this name is the query. And then as people start typing into the search field, you want to change what that name is and what is being queried from the server. And so that, so they asked, well, if I can't change what the query is, and I don't have, QLKit has parameters, but you just can't set them on a component at runtime, then how do I do that? And if you read my fact, there's very straightforward ways of doing it. What you have to do is you lift the concern of what the query is, what the search term is, into the level of the global application state. So basically, what you do is the component has a query that's static and it just says give me all the people that match the search term, but it doesn't say what the search term is. It just says I want the queries that match the search term, and then the search term itself is in the client application state, and then what QLKit offers is additional tools for helping to massage queries before they get to the server, and then at that point you say, okay, in order to answer this question, we can't do that in the client. We have to send it to the server. So now the server is going to have to know what the search term is, because it doesn't have that information for every client. So now we will add that as a parameterized query when it gets sent to the server. So it's just a different way of organizing it. But the goal is to simplify the query language. All components have static queries. You can't change them. You have to say what your data needs are when you write your code.
So the QLKit is built around GraphQL, right? I mean, this is completely driven by GraphQL. So it's not comparable to other toolkits which are decoupling backend and front end, like REST APIs or something like that.
Well, the idea is that QLKit uses a graph query language, and QLKit is another type of graph query language. It's a different. The two have a different syntax, and OhmNext and the Datomic Pull syntax are also graph query languages, and it has its own syntax. And all graph query languages are basically the same. They're solving the same problem, but they may have different syntaxes. And so it's easy to take the QLKit syntax and convert it to GraphQL if that's what you need to do. If you wanted to talk to a server with GraphQL, but the basic model is we have our own query language. You when a component asks for data, usually that those data needs are fulfilled through the application state that's in the client browser. But then there's like this extra stage where you can say, no, this piece of data, we don't have it in the client. We're going to have to ask the server for that. And then and then at that stage, you can actually change the query, because it might be that from the context of the server, it needs to know more about what you're querying, because it needs to know maybe who the user is, more about what the search term was. That was there may be extra things you have to specify to lock down exactly what it is you're querying. So we have extra parsing functions that let you introduce this extra information before it reaches the server. And then on the server, just like with OhmNext, we use QLKit too. So the exact same parsing library that you use for parsing reads and mutations against your client state in the browser, you use that exact same library on the server to parse the queries. And then when the data comes back, then there's again a set of parsing functions you can write that synchronize what's coming from the server with what's in the client state. And this is again a departure from OhmNext, because what OhmNext does is they have this concept of auto normalization, where the idea is that the process of when data comes from the server, we're going to incorporate that into the client state automatically, and the programmer doesn't need to do anything. But because of that, it places certain constraints on the structure of your client states, and the data that's coming from the server has to be in a very specific format. So QLKit just says, no, you just have to do it yourself, which makes things a lot simpler in some ways, but you have to write the code saying, okay, here's the data from the server. Now, how do I update my client state to match that?
So how much of this QLKit code is in production in your blockchain application? Or is it still...
So I guess we don't really have any production app yet. I mean, we're a company in a very sort of early space, and we're spending a lot of time trying to develop core technology. And there's a lot of efficiency gains that are possible by using graph queries, using Clojure, using core async is very useful here.
Yeah.
Those three things, like nobody in the blockchain, or very few people in the blockchain world, really understand how
Yeah.
powerful those things are.
Yeah.
And if you apply those to blockchain tech, there's major efficiency gains.
Maybe a quick intro about not intro, but a quick elevator pitch about what your company is doing, because
maybe can we just finish off the QL kit first, just before we move on. Just because I had a question about how the server fits into persistent data stores like Datomic or SQL Server or whatever, or Mongo, if you really want to go crazy.
Yeah.
But so just to kind of complete that and sort of close the circle a little bit, what do you do in terms of integration to persistent data stores?
Yeah, well, so the goal in a way is that what you want to do is when you describe the data needs for your application, what you do is you kind of invent your own language, which is the query language that your particular application has. So it might say, oh, well, this is an app for keeping track of providers, so we're going to have data. So in the query you can ask for providers, and then maybe you can say I want providers whose name begins with A. You can invent your own DSL basically describing this, and you're constrained because it has to match the underlying syntax of the QL kit query language, or if you're using OmNext or GraphQL, they have their own syntax. So you have to meet those basic requirements. But then after that, you can basically come up with any format of how you're going to ask for data that you want. And so with QLKit, you have the parsers on the server that will make it very easy to take this query that's coming from the client. And part of the goal here, as you touched on earlier, is that there could be different types of clients. There could be mobile clients, desktop clients, which would have very different types of data needs in terms of how much information they want. And with these parsers, you can very easily traverse the query and generate a result that's optimal for the type of client you're dealing with, without having to write multiple backends, which is kind of a popular technique these days. And but essentially that's where QLKit stops. So what all the best QLKit will do is it will give you a very precise language on the server that will tell you what data the client wants, and if it's doing a mutation, precisely what that mutation is, and additionally what data will be affected as a result of the mutation that needs to be refreshed on the client. So that's all QLKit gives you, and then it's up to you to decide where the actual data lives on the server, and you can convert it to GraphQL to use one of these GraphQL databases. You can convert it to a Datomic pull syntax to talk to Datomic. You can just use a state atom because it's a simple demo app. But it's totally up to you to convert that graph query into something that's meaningful for your server. So the goal here is that we're creating our own language, which for most people would seem like an insane idea, because it sounds like a lot of work to have your own language for every application you're building. But to a LISPer, they realize that's actually pretty easy. And OmNext, I think, to me, what made it compelling is just that it just said, forget about all these cursors and stuff. That just makes things complicated. Let's just say what everything needs, and then we'll just do the hard work of figuring out how to satisfy those needs, both on the client and the server. And guess what? Because it's Lisp, it's actually not hard. So that it's just the easiest thing to do anyway.
So you're doing a David, are you there? You're just leaving the persistence as an exercise to the reader.
Exactly. So you can do anything you want on the server.
Yeah. Oh, God. I want you to tell me the answer, Conrad. No, okay, great stuff. Sorry about so good. Right, we can move on to the stuff now. Thank you very much.
So, quick overview about what you're doing with Forward Blockchain, because I think some of the people might not be familiar with what you're trying to do. Maybe an elevator pitch about that one, and then the technologies. Then we can talk about blockchain and how Clojure is going to help with blockchain stuff.
Yeah. So what we're doing at Forward Blockchain is pretty basic. I mean, I've been part of the crypto community for a long time, and feel like I have a good overview of all the technology in the blockchain space, and and we just simply think that there's some kind of intersection. You can have Venn diagrams of like one Venn diagram is blockchain tech, and another one is medicine, and somewhere in the middle there's something useful there that that we feel we're sort of uniquely positioned to add value, and it's still early enough that it's really unclear what that is. Certainly, there's other companies working in this space, and many of them will have very clear plans saying, oh, this you should do this, and it's awesome. And we kind of look at what they're doing, and it's like, well, that doesn't really seem that awesome. It seems like you're basically just making a very complicated traditional database.
Yeah.
So that's kind of where we're at. So what we're trying to do is focus first on things on use cases that are really compatible with blockchain tech, and since blockchain tech by its nature is very public, if the most valuable types of blockchain technology are public in nature, because what you're trying to get is this validation property that a blockchain gives you, and your data has to be public to do that. So that means it's useful for public data sets. So these are things like provider information, like medical licenses, medical credentials, things like equipment inspections for like radiology equipment, things like figuring out the supply chain issues. Now, of course, as we're talking to people, I think there's still a lot of thinking in IT that sort of is pre-internet thinking.
Oh, yeah.
And in one way where that's the case is most programmers, when they learn their craft, they learn the idea that you collect data somehow, and now you have to put that data. Where are you going to put the data? Well, you're going to put the data in the database, right? And there's like one database, and this database, because this was before the internet, so you had like an intranet, and there was only one database. So where else were you going to put the data, right? And I think that the world now is different, and basically there's kind of four types of data now. There's data. There's data that's still the traditional type of data. You collect it, and it's like it has to be kept secret, and you want very strict controls about who's allowed to create that, and you can just keep that in a traditional database. But then there's other types of data, like there's data that's sort of communications data, and with communications data, you want to have a very low barrier to entry for people being able to author information. So you want people to be able to send your employees emails or something, so anyone can author that. But then you need very strict rules for who's allowed to read that data. You want privacy around reading, but you want no security at all around writing, or very low security. And then the most extreme type of data is stuff that is that we want to everybody to read and everybody to write. And this is kind of where companies are starting to get into social networking and putting information open and that kind of stuff. But then there's sort of this fourth category of data, which is data that is where you want very strict controls over who is allowed to write that data, but you want everybody to be able to read it. So like a medical license would be the perfect example. Only like particular employees in government should be able to update a medical license. But then once that has happened, you want everybody to be able to see it. And so that's kind of, those are the use cases that are really where blockchain really makes a lot of sense. So essentially what we want to do is, so the first system we've built out, and which we'll probably make publicly accessible, and we work with the Illinois Department of Professional Regulations to design the system. So it's a medical license system.
Okay.
For updating medical licenses and keeping track of medical licenses, and it runs on a public blockchain. And and what we want there is the fact is we have an answer now as to what the most secure way is to digitally sign information. The most secure way to digitally sign information is the Bitcoin and the Ethereum transaction signing mechanism. Why are those the most secure in the world? Because we now have multiple years of empirical data that people have stored billions of dollars in Bitcoin and Ethereum accounts, and nobody's been able to hack them by using the low-level mechanisms of these systems. So shouldn't we use those exact same digital signing algorithms to update a medical license? Right now, if you were to look at any kind of medical licensing system, the security there is relying on like one ASP.NET programmer that you hope is good that built the authentication system around that software, right? With our company, we don't want to be security experts because we have the world's most secure data structure, which is the blockchain, so we're working on that. Another really valuable use case is around what a lot of the problem is that there's so many hospitals in the world, and these hospitals have a lot of data that's valuable to companies. Maybe just in terms of like when people what's the current provider list in terms of who are employees and other information about what equipment they have. So there's a lot of data there, and there's very difficult issues around scalability for them to be able to there's no incentive for them to provide that data to outside companies because a company can't call up every hospital in the country and say, hey, we're interested in knowing how many of these types of radiological equipment you have. Can we buy that from you? Like, they can't have that conversation. So there has to be some mechanism for again, not patient data. We're talking just sort of facility and employee information where we can provide a scalable mechanism for aggregating that and giving incentives to hospitals to provide that data.
But where does Clojure and the thing that we talked about, like Clojure, and then you said Clojure is one of the probably your secret weapon for conquering blockchain. So where does Clojure come into the picture? So how do you use Clojure for blockchain?
Yeah, I mean, at the most basic level, so all web apps now are client-server applications. And what's happening now with blockchain is you have these things called dApps. These are applications that they basically have a bundle of HTML and JavaScript, that sort of provide the static assets for that application. But then the dynamic assets for that application are directly pulled out of a blockchain by the client without communicating with the server. Because that's the goal. The goal is to not have centralized failure points. And you want your client application to be able to directly communicate with the network. That's how you get the highest security, the highest reliability, and you don't have the deal with infrastructure for a data center. The problem there is that JavaScript programmers are used to the idea that they own the full stack, including the server. And the server can massage data in a very specific format that makes the life for the JavaScript in the client as easy as possible. So, the thing is that with blockchain applications, that's not the case. Data, when you write a properly optimized blockchain application in something like Ethereum that has smart contracts, and where you can write actual programming logic that's enforced by the blockchain, the data, the way that the data is structured on the blockchain, the top priority for the structure of that data is efficient validation by nodes inside of the network. It's not structured in a way to make application developers' lives easy. So what you end up doing in a dApp is your client application will have to fire off, maybe 50, 100 different queries to the blockchain that hit different parts of it. There's these log structures that you have to hit, and then there's also client local state that's within smart contracts, and you have to aggregate that all asynchronously in parallel, and then gather it and turn it into a meaningful data structure. And you have to do that in a way that's as performant as possible, and you have to do that inside the browser. And that's where core async and Clojure are your best friends, because with core async, it's very easy to fire off multiple requests to in parallel, and to have very clean bookkeeping in terms of, as the results come in, that you properly assemble a massaged piece of data that you can push into the UI part of your code. And of course, you can still do all of this with JavaScript. You can use promises, but it'll turn very ugly very quickly. And having a proper channel system with Go blocks and having Clojure is a big benefit there. And of course, this ties in directly to QLKit, right? Because what we want to be able to do in the UI is just say, a UI component should just say, I don't care what the blockchain looks like. Here's what I need. Somebody else needs to figure out how that maps onto resources on the blockchain. And then the parsers will figure out how to break those requests down into blockchain operations. And this goes beyond QLKit, because you need to have parsers that are wrapped inside of core async operations. So that's something we're going to release in the near future, so that you can actually essentially do this is not totally the right term, but you can basically do multi-threaded parsers inside the browser, because core async gives you something like a fake multi-threaded programming environment, which JavaScript doesn't have.
So soon we'll have a good library to deal with blockchain and Clojure then. But there are other initiatives like Status and District 0x or something. The guys are using Clojure. Those folks are using Clojure, and they are building dApps, especially Status people. They're building dApps on top of Ethereum blockchain, right? So
yes. No, I haven't had any chance to dig into their code base.
Okay.
There's so much stuff going on right now in the the blockchain world, and I know some folks at Status very well. There's only a small sort of Clojure community in this space, so I'm not sure exactly what they're doing. I haven't had time to dig into that, but we're definitely hoping to release a blockchain toolkit for Clojure and QLKit.
That's good, because I'm actually working on a blockchain startup as well, so we'll have to chat afterwards.
Awesome.
So off screen, we're going to talk about whether to sell Ethereum or not. Interesting.
Yeah, and so at this point, I just want to touch on one thing, which is that I think a lot of people that are kind of in on this call are functional programming geeks and stuff, and are wondering, is it worth kind of getting into the whole blockchain thing?
Yeah.
And so just one thing that is having been in the community for a while, it's clear that the blockchain community is kind of dysfunctional at the moment, and the reason for that is that obviously the main reason is because it has to do with money, right?
Of course.
What has happened is the reason I found back in 2011, I've been kind of in this for a while. Back in 2011, when I got into Bitcoin, what really appealed, what I found appealing about it, is that I'm trying to remember what the name is of that the bank robber with the famous quote. I can't think of his name now. But they asked him. No. But it's this old quote from this bank robber. But they asked him why he robbed banks. And his answer was, because that's where the money is, right? And so me as an enterprise employee for a long time, I always kind of felt like large companies undervalue their tech talent and place more value into like sales departments and into the sort of the management layer. And I think part of the reason why that was historically is that those people were more able to clearly show an ROI for their employment. So that, whereas in the tech world, we were always kind of on the very opposite side of the part of the business that brings in money. And so it was very hard to make a case for your value in an organization. So to me, like this cryptocurrency stuff, what at some level made it really exciting is that this is programmers that directly interact with money. At a fundamental level, and now we techies can have our our hands on the money strings, and
we own money,
and so that's so that's that I found that really exciting. But now, of course, the problem is that if you look at something like the programming language communities, I mean, we certainly have a lot of flame wars and arguments about static versus dynamic typing and stuff. But at the end of the day, somebody just said the bank robber was Willie Sutton.
Yeah, that's one of our viewer, Martin. He said Willie Sutton from live stream.
Yes, that was him. Yeah.
So we have the money as programmers.
Yeah. So we have the money. But part of the problem is now that if you look at the programming language community, if I'm having an argument with somebody who thinks static typing or Haskell is better than Lisp or whatever, at the end of the day, we both know that the reason we're having this argument is that for the most part, everybody has good intentions, and we want to actually figure out like what's the best answer, what is the better language, right?
Yeah.
So there's a certain limit as to how ugly things can get, whereas in the crypto community, especially with Bitcoin, things have gotten things get really ugly.
Yeah.
And again, it's the fact that there's money involved, and if you as a Clojure developer, if you go for the first time and you start reading these white papers that people are putting out in the crypto community, you'll see very quickly that some staggering amount of the projects that are coming out and that have what look like serious people backing them with a budget, like something like 99% of them are just fundamentally bad ideas, and at a technical level just wouldn't work. So, and maybe it's not quite that high. Maybe there are some ideas in there where I don't see the value, but I'm just amazed at how crappy the work coming out of the crypto community is right now from a technical level.
Yeah.
And the reason for that is that money is making it hard for people to figure out what's good and what's bad, because it prevents the quality work from rising to the top, because people will shout out the good work, and so there's a large noise to quality ratio there. And also the other problem is that it was very random. That like there's people that made enormous amounts of money in the crypto world, and the people that made that money was made in a very sort of random, haphazard way. So I really wonder at some of these large blockchain businesses like Consensus. It must be weird, because there must be like two programmers sitting next to each other, where one of them is 100-fold millionaire and the other one, doesn't have enough for lunch. Like, how do you run a company that way? I have no idea.
Yeah.
And that again adds so much distortion.
Yeah.
Now, of course, I think the answer. So anyway, so the reason I bring that up is just that people. I think a lot of people from the programming language world are going to, might get a bit turned off by that. And I'm just saying, unfortunately, this is true. And all we can hope is that that market forces eventually start coming into play, and that there will be more accountability, that your product has to actually do something useful, and that people that can produce good work start being promoted. But right now, that's just not the case. It's a wild west, and it's hard to figure out what is good and what is bad.
But it is interesting because in the beginning of the show we were discussing that to make the ideas, like complex ideas, accessible to people, and then that reminded me of the crypto kitties on Ethereum blockchain. That sounded like completely stupid idea, but then their paper all talks about like, oh, we're gonna bring in blockchain to people and to make people understand blockchain. But what do you think of CryptoKitty? Should I buy CryptoKitty now, or?
Well, I don't know. I think it's a great project. Now, the problem, of course, with it is that it's essentially just like another type of money, right? And it's very similar to money. Like, people have been trying to make a successful Ethereum game for a long time, including myself, but I never released anything because it was never good enough. And anything that's successful in crypto is basically just new types of money. So there's Bitcoin was successful, ICOs. So the reason Ethereum is worth a lot is because people make ICOs on Ethereum, but ICOs are just like another form of private money. And then CryptoKitties is another form of money. So there are like no other than like the idea of using a blockchain for money. No other idea so far has been successful, even though I personally believe the applicability of this technology is very wide ranging.
Yes.
It's kind of, in a way, kind of an embarrassment at how little utility these systems have after all this time, and that again is making it causing a lot of dysfunction, I think, in the blockchain community. And it's part of the reason, I think, also why there isn't like a lot of diversity, like there's no women or that kind of stuff. Which I mean, all tech sectors kind of have those kinds of problems, but I think in crypto it's particularly marked.
Yeah, I was going to say the other thing that I see happening as well is that people say, yeah, crypto, the whole blockchain thing is too hard. It's not offering value. I saw this presentation by a guy, ex-CouchDB guy, who's made this thing called FaunaDB. And what he's done is he said, okay, well, what we want from the blockchain is a distributed ledger. So actually, why do we need the blockchain? It's pretty horrible. So let's just write a distributed ledger system using Amazon Lambdas. So I think he's way off, because he's missing the point of the blockchain, which is this nature of the cryptography and the public nature of the data, and the fact that you can verify things and trust things. These are much more important than using lambdas to store shit. That seems like there's a sort of, people don't get it yet, I think. I think there's a kind of, the penny hasn't dropped. Certainly from the external perspective, it's just about making money. Oh, these big cryptocurrencies, shall I invest or shan't I invest? I think that's a really stupid question. The really better question is, what is this thing? How should it work? What are the benefits of this thing? And I think you've put it much better, which is that really what we're interested in is the security and the cryptography and the verifiability around this thing. Those are the key value propositions, if you like, of the blockchain. And all this other stuff is just bullshit.
Yeah, I mean, it's very tempting to say, hey, this blockchain is cool. Let's just stick it in our data center behind a firewall, and we'll just stick the same private data on it as we always have, and we'll call it a blockchain, and that somehow will be better than existing technology. And I think there are use cases for private blockchains, but yeah, it's really strange, right? I mean, I think us in the functional programming community, kind of understand this, because we've had conversations with people that are not into functional programming, and it's really hard. There's very smart people that you can talk to, and you can try to tell them why they should use functional programming, and it's hard to make a good argument for it. It's just like you either get it or you don't. Yeah. And you can be very smart and think that functional programming is just a giant waste of time. And that's the same thing around the public aspects of blockchain and the validation aspects of blockchain. Like that to me is where the story lies. But you can't really articulate a good reason for that. What you either people get it, or if they don't get it, they'll get it 3 or 4 years from now, once the technology has shaken out, and they'll see that all successful products in this space will use that aspect of it, assuming that the world ends up that way.
So before we get into that one, I want to take a couple of questions that we had on Twitter as well. So someone asked about Geraldo Lopez Souza. I hope I'm pronouncing your name right. I apologize if I didn't. So he says, how to mitigate the complexity of multi-methods to resolve queries on QLKit? What is the best approach to testing?
Yeah, so around complexity of queries. So this is kind of the cost of any kind of graph query system. Is the idea is that you have to actually parse these. You're creating these queries, and then the next thing you do is you have to parse them. And it's like, why the heck do I go through all this trouble, right? And so first of all, you don't have to use multi-methods with QLKit. You can use regular functions. You can just define a function for that handles reads or mutates, and then it will get it'll get the query as a parameter, and you can do what you need to do. So you don't have to use multi-methods. And then of course there's helper functions that handle the recursive aspect, where you have a query that has, you have a provider's list query, and then that has individual provider items in it, and then each provider has a name. So you can, so there's helper functions that let you handle that recursive side of things, which is really the most complicated part of it. So I mean, I guess that's. But at the end of the day, yeah, I mean the whole idea here is that unlike other frameworks, you're going to have to do a lot more work around parsing of queries, and the idea is that will give you more benefits in other parts of your application. And then the second part of the question, what was it again?
What is the best approach to testing in QLKit?
Yeah, so I think the testing story around these types of systems is really good. So there's kind of two things you want to test. One is the whole parsing, like if I send a query, will I get the right result? Now, QLKit makes a simplification. It maintains some global state that's used in the parsing process because, well, your parsers are just essentially taking data and then passing it off to children. And that starts getting tiresome. There's a lot of bookkeeping where you're kind of moving data around. So what we did is both in the browser and in the server side, there's a mount command where you can just say, here's everything about that we want to do. And then the parsers have access to that. And so for certain sort of global things, like, where does the state live for the global state? Like, you don't have to pass the state in, which is different from OMNext. Well, OMNext uses an environment system, so it kind of has a middle ground there. So the shoot, what was the question again?
Testing. Yeah.
Oh yeah, testing. So anyway, so the way you test, and you can see this in the QLKit tests that we have, is you just in a test you just mount a piece of data in the state, and then you can run a bunch of queries and see if they get the right answer, and then that's it. And then in your next test you can mount something else. So there is a stateful component there. The queries you don't just pass into the queries everything that they need. You have to first mount something that kind of initializes the parsing system, and then you can run queries against that. And then the other thing you want to test is the UI. And so the way React and the way OMNext work is that the render function returns a bunch of nested React components, and they have some weird system where they do that in a really light way with special constructors and stuff in JavaScript. So that's kind of hard to test, because it might be nice to write a test where you say, if this component gets this data, what will it look like? So with QLKit, we actually output essentially what is you would either call Sablono or Hiccup. So we just return an Eden data structure as the render result. And so now it's easier to write a test where you just say, this is the Eden that should come out of this component when it gets this state and these other properties. It's
more of a functional transform.
Yeah, so it's more like that. Now with the limitation that you still that event handlers, it's really hard to not return a function to handle an event in a when you're rendering. So if you do unit testing, you would just have to skip when you compare data structures. You'll have to skip over the event function because that it's kind of impenetrable at render time to test what would happen after the rendering when somebody clicks on this button or whatever. So anyway.
So the other, I think probably one of the last questions that somebody from the YouTube stream is asking, so because the Bitcoin has this inefficiency, with all the energy for using a lot of energy, etc. So the question is this a less of a problem for smart contracts like the medical licenses that you just explained, like the usage of energy and then the cost and efficiency?
Yeah. So the cost, So this is one of the largest flame wars in the cryptocurrency world. Is whether so there's two ways of maintaining consensus on a blockchain. Essentially, one is called proof of work and one is called proof of stake. And Bitcoin uses proof of work, and it requires basically running Bitcoin. Requires more energy than like the country of Ireland or something crazy like that. So and in fact, I think that Ethereum requires even more, which is people don't realize, because there's actually more computing power being put towards Ethereum than towards Bitcoin, because the mining rewards, the absolute amount of money paid to miners in Ethereum right now is actually higher than Bitcoin. because of how it's designed. They ended up just handing out more money to miners. But anyway, so both of them have this problem. But there is this thing called proof of stake, and I'm in the camp where I believe that it's like going to be a piece of cake to move over to proof of stake.
Yeah.
And proof of stake basically doesn't have any sort of energy efficiency, other than just a traditional data center would, where you just have to, you need servers to talk to, but it doesn't have to like burn, do complex calculations or anything and burn electricity the way proof of work does. And the problem is that for the people that say proof of stake is a bad idea, the only way to really prove them wrong is to get empirical data.
Yeah.
And so that will take time.
Okay.
The bigger thing, I mean, the big issue in 2018 for blockchain is scalability. How do we let people create transactions and move money around and call smart contracts in a way that's cheaper, where they can do it without paying high network fees? And that's a really difficult problem. Since we are able to kind of have some forward-looking approach at our company, we are working on some stuff in that direction.
Cool.
But it's technically very difficult. So the likelihood of success is, you have to keep that in mind, that we'll be able to come up.
Obviously, I don't want to, we don't want to get into this blockchain too much and then make this podcast about blockchain. Otherwise, we'll probably go into all sorts of directions. So I think one final question: Emacs or some other crap?
Definitely Emacs.
Okay, I think you win. Obviously, you win the internet now. I think it's been blow by blow for Ray now. These days, every guest that comes on, they say Emacs, and then Ray is like, "Oh my God, my life is meaningless."
I think it's like a random number system. You get a lot of fives. But we'll get a 6 eventually. I have faith.
Exactly. Yeah. I think we're almost 1.5 hours. Maybe we should just close down or at least close the recording by you've been remembering the stuff for sorry, not remembering. Somebody type remember. I'm just typing. I'm just saying what they say. You just posted something about the animation stuff. So a quick overview of that one. What are you trying to do there? It's like a generation animation.
So the basic idea is, I mean, we kind of have to look at what are like the big exciting problems in the world. And I think the most exciting thing in computer science really is machine learning and blockchain tech right now.
Yep.
But I just find it fascinating how important it is to be able to communicate with people, as I tried to do with my books. And it's clear that like Hollywood is essentially slowly turning into a giant animation studio. And so animation is really interesting in that it's actually kind of important. Like, there'll probably be the day where 5% of the world population is animators, because like these are like the last jobs that everyone's going to be doing is, feeding the machine learning systems and doing animation and stuff. And it seems to me that the technology for like the animation tools, there's like a lot of room for improvement there, and I'm no expert by any means, but I've used Blender and what is it called, Toon Boom and those kinds of things, and they all just feel like you're being thrown into the cockpit of an airplane when you first fire them up. There's just a million dialog boxes, and it's impossible to see how everything fits together. And I think what it really comes down to is where I think I see several different places where this can be optimized, and I've been working on my own development framework. And if you go on to forwardblockchain.com, there's a video there for our company, and all the animation there I actually built myself using my own animation tools from scratch.
Okay.
And the basic idea behind it is we want to apply functional programming to animation, which means that instead of building up these very brittle sort of scene descriptions that are all, where you like build this big tree of like what are all the objects, and when does this arm move there and when does that happen there, and everything is really brittle because it's you just build it once, and then if somebody wants to change, you like have to throw away a big piece of it because it's all very there's a lot of dependencies that make it hard to sort of disentangle things after the fact. And so this is a typical example where we want to use the functional programming style to it so that we can have composability of the different parts. And so the problem, and so the core problem in general with animation, I think, is that on the one hand, you want to be able to tell a story, and you want to think in sort of in a human way about animation, which to me basically means you think in terms of a storyboard. This person walks into the room, then they talk to that person, then they hand them this object, and that's kind of how a human would describe a story. But of course, if you want to take animation to its most primitive form, the most primitive form of animation would be something like a raw physics engine, where you just you simulate molecules bouncing around, and it's a very different way of that mechanistic way of thinking about the world is very incompatible with the way humans tell stories. And so a lot of these animation tools are fighting that divide. So like if you in an animation program, if you take an object and like a ball and one person throws it to another, what you do is you use something like a motion path, and you use things like easing, but then the animator, they have to do a lot of work, because then when the other guy catches the ball, they'll learn, they can't just catch the ball. The ball has to have weight, and then they learn that Springs, the motion path has to go down, and the person has to struggle to catch the ball and all that. And it seems like I think that there could be something interesting where you build a tool where you basically describe in a domain specific language in something like Eden what the different scenes are, and then you can attach to it physics properties to the objects and things, and then kind of have an algorithm that kind of reconciles the two. So it reconciles the physics with the storytelling. So if they have to throw a ball, it figures out how far they are apart and how high like you would throw a ball in that case. And if it guesses it wrong, then somebody can adjust it. But actually the way I'm building it is I'm basing it on a library called React Motion, which is a library an animation library for React, and it's interesting because it uses Spring animation for letting you have animation in your React app, and the amount of time it will take for an object to move from one place to another in React Motion changes depending on how far the places are that it has to move. So usually when we think of like doing animation in a website, we say, okay, I'm going to give 2 seconds for this. When the person drags this over here, it's going to take 2 seconds to go over there. But React Motion says, no. We have to take the physics into account. And so in React Motion, you just say, well, I want the object to be here. And then the library figures out how to get it there in the most natural, pleasing way. And so the framework I'm doing, it actually looks like React programming. You have a render function, but then you have another function for describing the physical properties of the components in the animation. And then you have another function where you can build out the storyboard for each component as it changes over time. So that's kind of roughly what I'm doing. And I just posted on a quick demo app that kind of shows how you would animate a ball using these kinds of ideas.
Yeah, I think we'll post the link on the notes of the show. I think we came almost to the conclusion of today's thing. Just a couple of announcements I want to make. One is that we have Dutch Clojure Day coming up on April 21st, Saturday in Amsterdam. So you're welcome to join if you want to come to Amsterdam on a nice weather. It's going to be a lot of tulips around, so it'll be lovely to have you there. I don't know if you ever been to Amsterdam, so consider this as a formal invitation from us.
Oh, thanks. It's tough. It's tough with a family to travel like that. So.
I think you should bring everybody. That's the whole idea.
When is it again?
You should bring everyone.
When is it again?
I think it's April 21st, Saturday.
Yeah, it'll be tough.
School time.
But anyway, so the call for proposals is still open. I'm not sure by the time we release the episode if it will be open. Probably because we're gonna end the CFP on end of February. And it's going to be an amazing day again. This is the third time we're organizing. And next week, Ray and I, and also Wouter, our maestro behind the scenes who fixes all our sounding issues, is also going to be there in Germany, in Berlin. So I'll be speaking there about Onyx, and Ray will be offending everybody there with his deaf jokes. So if you're around, please stop by and say hi. Once again, Conrad, thanks a lot for joining us. And there are a lot of topics that we discuss. You're doing this blockchain stuff, animation, QL kit, medicine, and writing books and stuff. And there is still a lot of things to talk about. So we'd love to have you back on the show.
Fun.
Yeah.
I'd be happy to come back sometime.
That'd be brilliant.
Perfect. That's it from us. I think you'll see this episode on the, we've been live streaming it, so we will try to do this every episode as well. And for the folks who want to see these videos later, we only restrict it to the people who, pay us with the money, real money. So we have Patreon. That's the idea. So if you think we're doing some useful job, go ahead and then click us and then show us your support. And the people who are supporting us, we are very grateful. And that's it from us on this nice springy Sunday from Holland. Goodbye.
Goodbye.
Yeah, great to meet you guys. It was a lot of fun. Bye-bye.
So I think it's a kind of dating application as well, So we don't want to get involved in that.